This is the third video in the series. We are going to now work on the str allocate exercise, implement the str allocate function. So let's go back to the kwrite, open on the main.c file that we were working on. I'm going to use the structure collapsing function of kwrite to just hide the code for the function that we already took care of, that is str length and str compare. Let's go back to the slides. We want to write a function str allocate, which takes as parameter a size, an integer size, and which returns the pointer, the reference of freshly allocated array, dynamical array of size +1 characters. So you tell me I want to str allocate 3, and I return to you a buffer, a dynamical buffer, which is of size 4 to accommodate for the mark of end of string. So let's go back to kwrite. We're going to take care of that right now. Char star, we return a pointer on char. The name of the function is str allocate int size. This is for the declaration. Definition is going to go here. So we're going to need a little temporary pointer here, char star tmp. Reason we need that pointer is simply to be able to store whatever we are going to receive from calling malloc. So the rule when you call malloc is you convert to the type of pointer you are using, in this case the pointer on char. Malloc by default returns and manipulate address that are like generic address, which mean void star pointer, generic pointer. So we need to make this conversion. Malloc is going to take as parameters the size that you want. So we want size of an int. This is a portable way to represent the size of a char. Sorry, this is a portable way to represent the size of a character. Times, well, depend on the parameter you passed to me. Okay, you want 3 times the size of a char, etc. So on our platform, a char is already 8 bits, 1 byte. But you need to use size of, just to make sure that if you port your program to a different platform where the char is differently represented, well, this program will still work correctly. Okay, so we have our tmp pointer, and then we can return tmp. Doing it this way has one advantage over directly returning the result of calling malloc, okay, which could be a possibility. Doing it this way with temporary pointer allows us to do this kind of check. If tmp exists, then I can do return the value of tmp. Else, if tmp doesn't exist, which mean else means that tmp was null. Null is a way of malloc to tell us that something went wrong, not enough memory was available or whatever. So if we are in the else statement here, that means malloc didn't do its job. We could just return null, okay, and let the calling program handle the situation. Or, because we have been storing our reference in tmp, we can also intercept this right here, and instead of just returning without thinking, we can try to do some error handling here. Alright, so I'm going to show you real quick how you can do error handling in such situation. P error. This is something that we didn't cover in class, so I'm just introducing so that you know. Problem with allocation. Should be more explicit here, but I'm just going for a fast solution here. So P error, print error, is going to display my little string, problem with allocation, along with a system error message based on what error flag malloc has set. And once I'm done, exit my program with error code 1. So this is one of the things I could do to handle the problem. Instead of just returning null, I just stop my application. This is a little drastic, okay, but this is for me to illustrate how to use the P error and exit to handle simple errors. When you guys take operating system, we are going to do much more error handling that we have been doing with C programming. I save this file. Let's check that everything compiles okay first. Clear. GCC main. No problem there. So now how do we test this little program here? Well, I can simply do something like char star p. Here goes a pointer which I'm going to initialize to null just for the sake of it. Here goes a pointer on character, and I can use this pointer on character to allocate, and then I will deallocate, of course, a string. So I would do something like p equals str allocate, and I want a buffer of size 20, and then of course I would free by memory. Save, compile, execute. So there is no explicit testing of that part. Okay, I just allocate the memory, deallocate it. Nothing crashed at runtime. This is always a good sign. Now, if I wanted to really make in-depth testing of this new functionality of my program, I would have then to make sure that the memory has been allocated, that I can fill it with 20 characters, 19 plus a mark of end of string, etc. But this is good for this example here. So we're going to stop for this exercise